So hello students, we are back to our session on Newton's law. So we've been discussing about Newton's first law in the last class. Now we'll be discussing about, obviously, Newton's second law. Okay, so you must have studied this equation, which is F equal to ma, right? This is such a popular equation, which is actually a particular case or a particular condition of second law. So this is not what second law means, but this is actually a particular condition of second law. Okay, so what then is Newton's second law? Okay, and you have to understand this is one of the most important law, okay, among the three laws, in the sense that more questions will be asked from the section. Okay, all right, so we'll answer that question, that is what is Newton's second law say? Okay, so it's simply that force applied will be equal to the rate of change in momentum. Rate of change in momentum. Okay. Appo total force on a body ennu parayunnathu, that will be equivalent to the change in the momentum of the body. അതായത് ഫോഴ്സ് ഉണ്ടാവുന്നത് എപ്പോഴാണ്? മൊമെന്റം ചേഞ്ച് ചെയ്താലേ അവിടെ നമുക്ക് ഫോഴ്സ് ഉണ്ടെന്ന് പറയാൻ പറ്റുള്ളൂ. ഓക്കെ, അപ്പോ time rate of change of momentum mathematically ഇതിനെ simplify ചെയ്ത് എഴുതുന്ന സമയത്ത് we can write it as F equal to delta P by delta T. Yeah, and what do you mean by the term momentum? എന്താ momentum എന്ന് ഉദ്ദേശിക്കുന്നത് എന്താ? Momentum is actually the motion in a body, motion contained in a body. Okay, അപ്പൊ നമുക്ക് എങ്ങനെ ഈ ഇക്വേഷൻ എന്ന് F equal to ma ലേക്ക് നമ്മൾ എങ്ങനെയാണ് എത്തിയത് എന്നൊന്ന് നോക്കാം. Okay, so let's take an example here. Let's take an example of a body of mass m. Okay, so we have m here, which is moving towards this direction with an initial velocity u. Okay, ഇങ്ങനെ പോയിക്കൊണ്ടിരിക്കുക, u velocity ഈ ബോഡി ഇങ്ങനെ പോയിക്കൊണ്ടിരിക്കുകയാണ്. u is a constant velocity, which means that it is in a uniform motion. Okay, അപ്പൊ പിറകുന്ന് നമ്മൾ ഒരു തള്ളു കൊടുക്കുന്നു. തള്ളു is force, right? So തള്ളു കൊടുക്കുന്ന സമയത്ത് we know that the position of the body will change, right? And also that its velocity will also change, right? Let's say now it has a velocity v. Okay, വേറൊരു വെലോസിറ്റിയിൽ ഇപ്പോൾ പോയിക്കൊണ്ടിരിക്കുകയാണ്. Okay, and that it takes a time t for that. Okay, so the force applied on the mass m moving with the velocity u, and we have the same body with another velocity v right here after some moment. Okay, so if we are to consider the momentum here, okay, initial momentum, final momentum ഒക്കെ എന്താണെന്ന് നോക്കാം. First case ആകുന്ന സമയത്ത് we know that p initial momentum, ആദ്യത്തെ momentum എന്ന് പറയുന്നത് p equal to mv ആണ് അല്ലേ? So m into v is u, and in this case we have p final is equal to m into v, right? So if we are to find out F equal to the force here, the amount of force here, then it will be delta p by delta t, right? But t സമയം എടുത്തിട്ടാണ് ഈ ഒരു ചേഞ്ച് ഉണ്ടായതെന്ന് വിചാരിക്കാം, മൊമെന്റത്തിൽ ചേഞ്ച് ഉണ്ടായതെന്ന് വിചാരിക്കാം. Then we will have m into v minus u, right? m into v minus u divided by the time taken. Or in other words, we can actually see this. This is actually m into acceleration, right? So we can write it as F equal to ma. Okay, so why is this a particular case? എന്തുകൊണ്ടാണ് നമ്മൾ നേരത്തെ particular case ആണെന്ന് പറയാൻ കാരണം? Here we know that the mass doesn't change as the object moves. ഇവിടെ mass മാറുന്നില്ല, mass remains the same. Okay, again let's go back to the equation, that is delta p by delta t is equal to force applied. Okay, here delta p എന്ന് പറയുന്നത്, അല്ലെങ്കിൽ p എന്ന് പറയുന്നത് mv ആണ്, or we can say delta p is delta mv, right? And this stands for both. That is, ഇവിടെ mass change ചെയ്യുകയാണെങ്കിൽ എന്ത് സംഭവിക്കും? Momentum change ചെയ്യും. That is, if m changes, momentum will change. If the velocity changes, the momentum will change. Or if both change, m and v change, momentum will change. Right? അപ്പോൾ ഇതിൽ ഏതെങ്കിലും ഒന്നായാൽ തന്നെയും there will be a force applied. Okay. നമുക്ക് ഇതിനൊരു എക്സാമ്പിൾ, മൊമെന്റം മാസ് ചേഞ്ച് കൊണ്ട് എങ്ങനെ മൊമെന്റം ചേഞ്ച് ആവുന്നു എന്നുള്ളതിന്റെ ഒരു എക്സാമ്പിൾ കാണാം. Okay. Imagine we have a rocket. Okay. Okay, this doesn't look like a rocket, but imagine that this is a rocket. Okay. Rocket is moving up. All right. And we know that the exhaust gas from the rocket comes down. Right. അപ്പോൾ ഇതിനകത്തുള്ള ഫ്യൂവൽ ആണ് എന്തായിട്ട് മാറുന്നത്? എക്സോസ്റ്റ് ഗ്യാസ് ആയിട്ട് പുറത്തേക്ക് പോകുന്നത്. Okay. And exhaust gas is actually the fuel, right? ഇതിനകത്തുള്ള ഫ്യൂവൽ ആണ് എക്സോസ്റ്റ് ഗ്യാസ് ആയിട്ട് മാറുന്നത്. Fuel actually contributes to the mass of the rocket. Okay. അപ്പോൾ ഇവിടെ we can see that the mass changes. Here we cannot no longer use the equation F equal to ma. ഇവിടെ വാലിഡ് അല്ല ഈ ഇക്വേഷൻ. ഇവിടെ what is valid is ഇവിടെ എന്നല്ല എല്ലായിടത്തും വാലിഡ് ആയിട്ടുള്ള ഇക്വേഷൻ എന്ന് പറയുന്നത് F is equal to change in momentum by change in time ആണ്. Okay, this equation is valid everywhere. Okay, and here what we'll have to do is we'll have to consider the change in mass as well. Okay, അപ്പോൾ ഓരോ കേസിൽ ഇങ്ങനെ മാസ് ചേഞ്ച് ചെയ്യുന്നതിനനുസരിച്ച് വെലോസിറ്റി ചേഞ്ച് ചെയ്തതിനനുസരിച്ച് we know that the force changes. അപ്പോൾ ഇതിനൊരു ഇക്വേഷൻ വേണം, കുറച്ചും കൂടി സിംപ്ലർ ആയിട്ടുള്ള ഒരു ഇക്വേഷൻ വേണം. ഓക്കെ, അപ്പോൾ അതിനു വേണ്ടി we are actually deriving an equation which we can actually call as the differential form of Newton's second law. Okay, let's see how it can be written. F equals delta P by delta T, which again is, if we are to choose the intervals to be very, very small. Okay, ഈ ചേഞ്ച് വളരെ കുറച്ചാക്കി എടുക്കുന്നതാണെങ്കിൽ we can actually write it as dp by dt, right? Which we can further write as d by dt of mv, right? Is equal to mdv by dt of v plus v dm by dt, right? So we now have reached at this equation, that is F equals m dv by dt plus v dm by dt. So this is more of an exact equation, alle? F equal to ma എന്ന് എഴുതുന്നതിനേക്കാളും കുറച്ചും കൂടി വൃത്തിയുള്ള ഇക്വേഷനിലേക്കാണ് നമ്മളിപ്പോൾ എത്തിയിരിക്കുന്നത്. ഓക്കെ, റോക്കറ്റിന്റെ കേസിലോ അല്ലെങ്കിൽ മാസ് ചേഞ്ച് ചെയ്യുന്ന വേറെ ഏതെങ്കിലും ഒക്കെ കേസിൽ നമുക്ക് എന്ത് ചെയ്യാം, ഈ ഇക്വേഷൻ ഉപയോഗിക്കാം, റൈറ്റ്? അതായത് ഇവിടെ നമുക്ക് അറിയാം മാസ് കോൺസ്റ്റന്റ് ആവുന്ന സമയത്ത് our equation will become F equal to ma, right? This term cancels, right? V ആണ് കോൺസ്റ്റന്റ് ആവുന്ന സമയത്താണെങ്കിൽ this term cancels, right? So that's what happens here, and this is called the differential form of Newton's second law. Okay, now let's go into discuss about some examples of Newton's second law. Okay, some problems that would be. So let's consider a floor, okay, onto which we keep a block of mass m, block of mass m, okay, and let's say somebody is pushing the mass, പുറത്തുനിന്ന് ഒരാൾ തള്ളുന്നുണ്ട്, let's say a force F. Okay, so ഒരു ഫോഴ്സ് ഉപയോഗിച്ച് അതിനെ തള്ളിക്കഴിഞ്ഞാൽ we know that it will accelerate, right? it has been at rest, restilirikkunna mass aanu, adine mele oru force apply cheyan. We know that it will change its velocity, because at rest it will change its velocity, which means that it will have an acceleration here. It will accelerate, right? Acceleration, we know that it will be in the same direction, right? ഈ ഡയറക്ഷനിൽ തന്നെയല്ലേ acceleration ഉണ്ടാവും. ഫോഴ്സ് ഏത് ഡയറക്ഷനിലാണോ, നെറ്റ് ഫോഴ്സ് ഏത് ഡയറക്ഷനിലാണോ അതേ ഡയറക്ഷനിലായിരിക്കും എന്തുണ്ടാവുന്നത്, acceleration ഉണ്ടാവുന്നത്, right? Now how do we solve this? How do we find out the acceleration, the value for the acceleration? Okay, അപ്പോൾ നമുക്ക് കണ്ടുപിടിക്കേണ്ടത് acceleration എത്രയാണെന്നുള്ളതാണ്. അപ്പോൾ നേരത്തെ മുന്നേ ചെയ്തുകൊണ്ടിരുന്ന പോലെ, here the first step is that we draw the free body diagram of the body M. Okay, അപ്പോൾ point object ആണ്, forces acting on the body എല്ലാം നമ്മൾ കാണിക്കണം അല്ലേ. അപ്പം we know that there is acceleration due to gravity downwards, sorry, the force due to acceleration due to gravity, which is mg, right? And there will be a contact force, which is the normal reaction that will be acting upwards, right? And we know that there is a force which is acting along the positive x direction, and which has a value f, right? And we know that acceleration is in this direction, right? Or in the mark here, this is mg, this is f, this is n, that is applied by the surface onto the body, right? But ഇത്രയും forces ആണ് ഉള്ളത്, and we know that there is no vertical movement for the body. Okay, body up or down move ചെയ്യുന്നില്ല, അതായത് y directionally it has no motion. Only motion it has is in the x direction, which means that the upward force will be equal to the downward force, that is n will be equal to mg here. Okay, f in a balance here, there is no other force, and we know that f is making the body move in that direction, right? So if we are to take the Newton's second law, we can write it as f net will be equal to mass into acceleration. Here we are assuming that there is no change in the mass of the body, so it will come down to m into a, right? Yes. So ഇതിന്റെ അകത്തുനിന്ന് acceleration will be equal to f net, that is f itself. Here it is f itself, so f by m. Okay, so that's what we get here. Let's move on to the next question. Okay, imagine that there is a surface onto which, okay, there's a surface onto which a body is kept. Okay, and somebody is applying a force onto the body from the left side. Okay, somebody is pushing it. And somebody else is pushing it from the right side. Okay, so here we have two forces acting. Say F1 in this direction and F2 in this direction. Okay, and let's say F2 is greater than F1. Then we'll know that the body will be moving. F2 is larger, so the body should be moving in this direction, right? So here we have to find out the acceleration. Here also we have to find out the acceleration. So what do we do here? Here we have to consider all the forces, right? So drawing the free body diagram, then we will have mg acting downwards, n acting upwards, right? And then we have F2 acting in this direction. Exactly opposite, we have F1 acting in this direction, right? So mg n F2 here and F1 here. Okay, so when looking at it, we know that there is no movement in the vertical direction. Body മേലോട്ടേക്കോ താഴോട്ടേക്കോ move ചെയ്യുന്നില്ല, which means that n will be equal to mg. There is no doubt in that. And the body has only acceleration in which direction? X direction, right? So ഇവിടെ നമ്മൾ total f net എന്ന് പറയുന്നത് f net will be, it will actually be equal to f2 minus f1, right? F2 is bigger, so it will be f2 minus f1. right? And from Newton's law, we know that this is equal to mass into acceleration. F net is actually equal to mass into acceleration. So we will get it as F2 minus F1, or the net acceleration or the acceleration of the body will be equal to F2 minus F1 by M. Okay. By M. So this will be the acceleration of the body. Okay. So let's do another problem. Let's move on to do another one. And here we have again body kept right here. And let's say ഇവിടെ ഫോഴ്സ് എങ്ങനെയാന്ന് വെച്ചാൽ സൈഡും കൂടെ കാണിക്കാം. ഇവിടെ somebody is pulling the body in this direction. ഇങ്ങനെയാണ് ബോഡീനെ പുൾ ചെയ്യുന്നത്. Okay. And let's say the angle it makes with the our x-axis is, let's take it as theta. Okay. The angle theta ആണ്. ബോഡിയുടെ mass m ആണ്. Okay. And this is the force applied onto the body. Okay. Now here we have to find out both the acceleration and the normal reaction on the body. രണ്ട് കാര്യങ്ങളാണ്. Find acceleration. Second one, normal reaction. Okay. ഈ രണ്ട് കാര്യങ്ങളാണ് നമുക്ക് കണ്ടുപിടിക്കേണ്ടത്. Alright. So let's do this. എങ്ങനെയാണ് ചെയ്യേണ്ടത്? Free body diagram വരയ്ക്കണം അല്ലേ? The first step is to draw the free body diagram, right? So when you draw the free body diagram, you have the body here as a point mass, and then you have to mark all the forces acting on the body, that is mg acting downwards, and then we will have n acting upwards, right? N acting upwards because the surface, this thing is perpendicular to the surface, right? അതുകൊണ്ടാണ് upwards എന്ന് പറയുന്നത്. സർഫസിന് പെർപെൻഡിക്കുലർ ആയിരിക്കും normal reaction എപ്പോഴും. Okay. And we have another component, that is the component of force that is in this direction, right? ഈ direction force in a component കൂടി ഉണ്ട്. N here, mg here, and you have F here. Okay. Here again we'll have to make the force into x and y components. അല്ലേ? X and y components ആക്കി നമ്മൾ ഫോഴ്സിനെ മാറ്റുകയാണെങ്കിൽ here it's given, the theta is given here അല്ലേ? ആംഗിൾ തന്നിട്ടുണ്ട്. theta ആണ് ഇത്. പറയുമ്പോൾ ഇതിന്റെ x component എന്ന് പറയുന്നത് it will point from here ഇങ്ങനെ ഒരെണ്ണമായിരിക്കും അല്ലേ? This will be the x component, and we know that the y component will be something like this, right? So y component ingane kittum, x component ingane kittum. So this will be fx and this will be fy, right? And we know that if a direction lana object na pull cheyyunnathu, so it will have an acceleration in this direction. Here also we know that it has no vertical movement. Up and down move cheyyunnilla, floor lude parannu povuvana cheyyunnathu. Appo endu cheyyana? Ivide it has acceleration only in this direction. Okay. Appo again we can say that we can actually equate the y components, positive y and negative y. That is, we will get mg equals fy plus n. Fy, in other words, we can say fy is f sine theta, right? So it is f sine theta plus n. So mg is f sine theta plus n, or we can write n equals mg minus f sine theta, right? And this is n. Okay. That's how you equate the vertical components, that is the components in the y direction. Let's look at the component in the x direction. So in the x direction we have f cos theta, right? So f cos theta, this is the f cos theta, fx is f cos theta. So F cos theta is actually responsible for the whole motion of the body, right? In the horizontal direction, which is equal to mass into acceleration, or in other terms, we can write acceleration as F cos theta by m. Okay. So are these things clear? Is there any doubt or anything? If there is some, you can actually contact me and clear your doubts with me. Okay. And now I'll be giving you another question for an exercise. So I want you to take this down. Okay. So this is an interesting question. Okay. I want you to take this down. Question is, say we have a body right here, a body of mass m kept right here. Okay. ഇനി ഇതിനു മുകളിൽ ആക്ട് ചെയ്യുന്ന forces, the force is acting on the body. There is a force coming in this direction. Sorry for that. There's a force acting in this direction. Okay, and there is another force acting in this direction. Another force acting on the body in this direction. Okay, say this has a value 20 Newton. The 20 Newton under the vicharikkam is the magnitude of the force, and here let's say it's 10 Newton. Okay, and mass of the body, let's take it as say 5 kg. 5 kg mass, and yeah, we need the angles, right? The angles in here, let's say the angle made by this force component with the x-axis is 37 degrees. Okay, and the angle made by the 10 Newton force component, let's take it as 53 degrees. Okay, so ഇത്രയും കാര്യങ്ങളാണ് തന്നിട്ടുള്ളത്. മാസ് ഉണ്ട്, forces ഉണ്ട്. Force 1 is 20 Newton, force 2 is 10 Newton. Okay, this is the mass of the object and these are the angles. Okay, so here you have to find the normal reaction experienced by the body, and you also have to find out the acceleration of the body. Okay, so this is the exercise, and I'll be discussing this exercise in the next video, and I want you to actually submit this assignment. Okay, so till now we have been discussing about bodies with single blocks, right? So ഇവിടെ രണ്ട് ബ്ലോക്സ് ഒരുമിച്ച് വെച്ചിരിക്കുകയാണ്. ഓക്കെ, അതിന്റെ മുകളിലാണ് ഫോഴ്സ് അപ്ലൈ ചെയ്യുന്നത്. സേ a force is applied onto this block. Okay, and say the magnitude is F. Okay, അങ്ങനെ force apply ചെയ്ത് കഴിയുമ്പോൾ we know that this M1 will start to move, right? It has been at rest. റെസ്റ്റിലിരിക്കുന്ന രണ്ട് അടുപ്പിച്ചിരിക്കുന്ന ബോഡിന് മുകളിലേക്ക് ഒരു ഫോഴ്സ് അപ്ലൈ ചെയ്യാണ്. So we know that the M1 will start to move with a certain acceleration. What about M2? M2 will also move with the same acceleration, right? They will go together with the same acceleration. Here also we need to find out the acceleration of the block. So the first thing to find out is to find out the acceleration of the block, and the second thing is to find out the normal reaction. Normal reaction ഏതെന്ന് ചോദിച്ചാൽ ഈ ബ്ലോക്കുകൾക്ക് ഇടയിലുള്ള normal reaction. Okay, ഏത് surface of contactകൾക്കിടയിലും normal reaction ഉണ്ടാവില്ലേ? So here we need to find out the normal reaction between the surfaces of the block. Okay, അത് മാത്രമല്ല ഇവിടെ ഉള്ള normal reaction. We know that there is normal reaction always at all points of contacts, right? All surfaces. So let's find it out. Okay, So here also, let's draw the free body diagrams first. The first step is to draw the free body diagram. So M1 ന്റെ free body diagram വരയ്ക്കുന്നതെങ്കിൽ, let's not talk about the vertical components. Okay, vertical components എല്ലാം cancel ചെയ്ത് പോകും. ബാക്കിയുള്ളത് horizontal components. Let's look at them. Okay, അപ്പോൾ here we know that mg n1g താഴെയുണ്ട്, m2g താഴെയുണ്ട്. Let's not talk about that. And n is cancelling it. Let's not talk about it. Okay, so between them, that is between m1 and m2, m2 is actually applying a force onto m1, which is the normal force. Okay, so there is a normal force applied onto m1 by m2. Okay, and there is another normal force applied by m2 onto m1. Okay, so that's the force here. And we have to talk about other forces. Okay, let's draw the free body diagrams first. For m1 India, this is m1. Okay, m1 in the mole act in the forces. Let's denote all the forces. For the sake of it, let's denote all the forces. Okay, for mg downwards and down, right? And then you have a normal reaction which is acted upon m1 by the blue surface, right? അത് കാരണം ഒരു normal reaction ഉണ്ടാവും. Let's take it as n dash. ഇതിനെ n എന്ന് എടുത്തല്ലോ, അതുകൊണ്ട് ഇതിന് it should be different, right? So let's take it as n dash. This is m1g. Okay, and there is a force applied onto m1. m1 ന്റെ മുകളിലാണ് ഈ force applied ആവുന്നത്. So that should be denoted here, and that is f in this direction. So there is f in this direction, and we know that the acceleration is in this direction, right? So this is the, is this complete? No, it is not, right? So there is one more force applied onto m1 by m2, right? So that is the normal force applied by m2. But in direction, let's denote it here. From that will be this direction, and it's n. Okay, so this is m1 in the free body diagram. Okay, let's draw the free body diagram for m2. Okay, point mass and denoting all the forces acting on it. m2g downwards, some n double dash. Okay, a different one. So we'll denote it with another letter. That is all. Okay, n double dash. And is there a force in this direction? This direction will force and it's there, right? There is force applied by m1 onto m2, right? Normal reaction is there, which is actually equal to n, right? E force in anomaly consider. Okay, so these are the whole total forces acting on the body m2, right? Appo idine namukku again we'll equate the forces. We equate cheyna samayathu we know that n dash is equal to m1g, because there is no vertical movement for the body, right? And we have force net. The net force is equal to m into a net. Here m is m1, so m1 a net. Okay, net force ഇവിടെ calculate ചെയ്യുന്ന സമയത്ത് the body is moving in this direction. Force ഈ directionലാണ്, f ആണ് ഈ directionൽ, n opposite directionലാണ്. Accelerationന്റെ direction എന്താണോ ആ direction നമ്മൾ positive ആയിട്ട് എടുക്കും. Okay, അപ്പോൾ അതിന് opposite ഉള്ള direction should be negative, right? അപ്പോൾ ഇവിടെ നമ്മൾ total force calculate ചെയ്യുന്ന സമയത്ത് that will be f minus n. Minus comes because this is opposite to the direction of acceleration. Okay, so f minus n dash will be equal to m1a, or here a will be equal to f minus n dash by m1. Okay, and in this case, let's look for the forces here. Here we know that m2g will be equal to n double dash. Okay, and the force net, the net force is solely due to the normal reaction, right? That is n. Here we can write it as m2a, right? The m2 so m2a is equal to n. Okay, so what did we want to find out? We wanted to find out the normal reaction, right? So the normal reaction is obtained as m2 into a, right? And we need to find out a as well. A കണ്ടുപിടിക്കണം. A കണ്ടുപിടിക്കാൻ എന്ത് ചെയ്താൽ മതി? F minus n dash by m. That will give us the value for a. Or we can actually write it as, we can actually take the two equations, that is this one. Let's take this one. This one as 1, and let's take this one as 2. What happens if you add 1 and 2? 1 and 2 add in the we have f minus n dash equal to m1a, right? We also have n equals, so sorry, this is not n dash, okay? I made a mistake here. So here we have n dash equal to m1g. Here f net is f minus n, okay? Sorry for that. It is, please clear it, okay? This is f minus n. There is no n dash here, it's just n. Okay, so n is equal to, we got it as m2a. So adding the two, we will get f equal to m1a plus m2a, right? Or we can write f equals a into m1 plus m2, or a equal to f by m1 plus m2. So here the acceleration of the body is equal to the force applied divided by the mass of the body, the total mass of the system, right? And the normal reaction, that is equal to m2 into the acceleration, okay, whatever is here. All right, so this is how we solve this problem. Okay, now I will be giving you an exercise, okay? And the exercise is like this. Here we have 3 bodies, okay? 3 bodies kept together, stuck together like this. 3 bodies of different masses, okay? Should be in contact. All right, so each body having, say, this is 2 kg, this is 3 kg mass, and this is 4 kg, okay? And let's say a force of 18 Newton, okay? Say 18 Newton is applied onto the body too, okay? What I want you to find out is, the first question is to find out the acceleration of the blocks, okay? So you have to find out the acceleration of the block, and the second thing, I want to find out the normal reaction between 3 kg, 3 kg block and 4 kg block, okay? So this is the question. I want you to try this question and submit this as an assignment, okay? All right then. I think you know how to do it, right? You can just refer to the last problem and then try doing it, and if it's difficult to solve, you can contact me, okay? Now let's move on to do a different set of problems. And here again, the floor here, sorry, the floor here, and say 2 bodies of masses m1 and m2 are kept on the floor like this. Okay, and say they are connected by a string. They're connected by a string, by a massless string particularly, and there is a force applied onto them. Okay, say there's a force applied onto this block, and let's call it F. This is M1, M2. Okay, so if you have to apply a force onto M1, which is connected by a string onto, sorry, if you have to apply a force onto M2 and that is connected to M1 by a string, both will start to accelerate, right? And will it be the same? Will the acceleration be the same? It will be the same, right? So the acceleration here will be the same as the acceleration here. Both will speed up or slow down to the same value, right? So what we have to find out here is we have to find out the acceleration. First thing is to find out the acceleration, and the second thing is to find out the tension in the string. Okay, so let's see how it can be done. Again, going back to thinking about the free body diagram, right? So we can draw the free body diagrams here. So for the first one, for M1, we'll denote all the forces acting on it, right? So there is M1G acting downwards. There is normal reaction, which is acting upwards. And we know that here there will be a tension acting in this direction, right? Away from the point of contact along the string. Here also, it will have, there will be a tension, right? Since both are acting on the same massless string, it will be the same, right? So there is a tension acting in this direction, which we can denote by the letter T. Okay, T, N, and M1G. Okay, so that's clear. And let's draw the free body diagram for M2. So this is as that of M1. Now of M2, we have, there is M1G acting down, sorry, M2G acting downwards. There is a normal reaction, which will be different. So let's denote it by the letter N dash. And there is a force applied in this direction, right? And T is acting in this direction, right? So denoting the forces, we have M2G acting downwards, N dash upwards, F in this direction, and T in this direction. Okay, so obviously we know that the acceleration is in this direction, which will be taken as the positive direction, right? So solving this, we will have the equivalent motion of the body, or the acceleration of the body is in the x direction. So F net, that is equal to M1A will be equal to, and will be solely equal to, tension in the string, right? And here when we look at it, F net will be M2A, right? So M2A, that will be equal to, the force net here will be acceleration in the F direction, so F minus T. So F minus T is equal to M2A. Okay, so we can actually write it as we have T here, right? T's value is M1A, right? From this, T is M1A. So F minus M1A is equal to M2A, or F is equal to M1 plus M2 into A, right? Or we can write it as, we can write acceleration as acceleration equal to F by M1 plus M2. So that's the answer for the first question. So what about tension? Tension is equal to M1 into acceleration, right? From this equation, right? From the first equation, we can write it as M1 into A, that is F by M1 plus M2, right? That will be equal to the tension in the string. So that's the answer for the second one, second question. Get it? I hope you get it. And I want you to try another problem. Okay. So let me draw the question here. Also, we have 3 blocks connected. Okay. So in a similar fashion, you can actually solve this problem. We have 3 blocks connected by strings, and they're kept on the surface. So in between the two, there's a string, and in between these two, there's another string. Okay, and the last one, a force is applied onto the last one, which is equal to, say, 6 Newton. Okay, and the masses, let's say this is 2 kg one, this is 1 kg, and this is 3 kg. Okay, so what I want you to find out is, the first thing, the acceleration of the blocks, and the second thing, the tension in both the strings. Okay, so there will be a tension in the string, and there will be another tension in the string. Say this is T and this is T dash. Okay, so find out T and T dash. Yeah, that's a bit confusing, but yeah. All right, so that's it. That's the question. Okay, and now we'll be discussing about pulley systems in the next session. All right, so thank you for listening and have a good day. Bye bye.